Okay, I always have to tell everybody where I am. I'm after school with my wonderful chemistry students. This is Chemistry Club. Okay, so what I want to do before I forget, I want to talk a little bit about class today for 8th grade science. We talked about a lot of different things, and I didn't make a movie about it. We got so excited about certain things, yes? We talked about carbon dioxide. Remember, carbon dioxide looks like this, and it's a particle. We have a visitor. When we talk about chemicals, when we talk about molecules, they have a certain arrangement of electrons. That's really what we're talking about, isn't it? Because chemistry, as we know, is the study of electrons. My chemistry students are looking at me like, God, that's not what we're doing, because it's more like a math class, isn't it? Yeah, it's more like a math class. We're working with data reduction, significant figures, scientific notation. When you're in chemistry, you'll be doing a great deal of that. But right now, we're talking about what the actual study of chemistry is, and it's a study of the electron. How the arrangement of electrons and atoms give a molecule or a particle a certain set of properties. For instance, we talked about in Africa, where you had this volcano, and this volcano was next to a valley, and the volcano was filled with a lake. Okay? Lake, right? And unbeknownst to the people in the village thought that it's an inactive volcano. Right? It's an inactive volcano. Well, what happened was that one night, everyone's here sleeping in their houses, and the lake literally burped up enormous quantities of carbon dioxide from what they thought was an inactive volcano from the ground. It burped up all of this carbon dioxide that was building up. The water pressure holds the carbon dioxide down. Yes? So what happened was all of this carbon dioxide comes down the side of the mountain, and carbon dioxide is very dense. That's why it's very dangerous in your homes not to have carbon dioxide and carbon monoxide detectors, because the carbon dioxide is heavier than air and will trap near the ground, and these poor people, they died in their sleep. Correct? Carbon monoxide is dangerous because it will successfully compete for space on the blood cell relative to oxygen. If you have oxygen and carbon dioxide, it'll take the carbon monoxide. If you have carbon monoxide and oxygen, it will take the carbon monoxide. So having those detectors in your home is very, very important. Clear? Okay. So that simply shows you that every element, every molecule, they have unique sets of properties. Okay. I have a liquid. It's colorless. It has no odor. It's clear. It boils at 100 degrees Celsius. It freezes at 0 degrees Celsius. Yosef is dying to tell me the answer. He's going crazy. It has a specific heat capacity of 4.18 joules per gram degree Celsius. It has a density of 1 gram per cubic centimeter. What is it?
Water.
It's water. It's water. Well, how did I identify that? Well, I used properties. Properties that are consistent with particle. In this case, a molecule of water. Clear? Water has that shape. I think I went over that. 109 degrees, yeah? 109.5-ish. So, carbon dioxide. We also talked about this. We talked about fission and fusion. Why are we talking about fission and fusion? Well, underneath this lake, there's a lot of stuff going on under here. A lot of stuff. Has anybody ever heard of Yellowstone National Park in the western United States?
I've been there.
You've been there. And where are you from originally?
Ecuador.
Ecuador. Somebody from Ecuador has been to Yellowstone. I'm from the United States. Never been. Amazing. Excellent. You have hot springs. What makes those hot springs hot? Does anybody know? What makes those hot springs hot?
The heat underground.
The what?
The heat.
The heat underground. Okay. Well, what makes the heat underground?
Lava and stuff.
Lava and stuff. Okay, excellent. Lava and stuff. That's absolutely correct. But what's the stuff? What does that mean, lava and stuff? Lava and stuff. My kingdom for some board cleaner. Lava and stuff. Here I have the ground. Here I have giant volcano. I have the lava. Magma, lava, right? One's in the ground, one's out of the ground. Molten rock. What melts the rock?
The heat.
Heat. What causes the heat?
The movement.
Nuclear fusion. The splitting of the atom. The releasing of vast quantities of matter due to the splitting of the nucleus. Radioactive decay. Fission. Nuclear fission. That's what causes it.
So where is this?
I take uranium and I split it into two lighter elements. Fission. What's fusion? Where does the heat from the sun, where does it get its energy from? How does it get its energy? The sun is bright. Is the sun hot?
Yes.
How do you know?
But the nitrogen, it has nitrogen. Yes.
Is the sun hot? How do you know the sun's hot?
You feel.
No, you don't. You don't feel the sun. You don't feel the heat of the sun. That's for another day. That's confusing. We don't know the sun is hot. What do we feel? You're in outer space. Outer space is frozen. There's no heat there.
Energy.
Another day. But where does the sun get its energy from? Fusion. Fusion. In the ground, you have fission. That's where the earth gets its energy to melt the rock. The sun uses fusion. If I take hydrogen, that's fusion. It's more complicated than that, but I take hydrogen and hydrogen, I make helium. The production of helium. Very complicated, but yet very simple. Not that complicated, but fusion. We are experimenting with fusion reactors. I spoke about it in class, remember? The tokamak, it's a Russian design in Princeton, New Jersey. Last time I was there was 1986. Their electricity bill was $1 million a month. 300 million degrees inside the tokamak reactor, and it was suspended and didn't hurt anything around it because the plasma, the hot plasma, was surrounded by magnetic fields. Amazing, isn't it? I think that's about it. We did other things. And what I'll do on, what's today? Tomorrow's Thursday, so Sunday we'll meet again. I'll start off Sunday's class with a video to review things that we talked about today. Good? We're off.